Okay guys, so in this video we're going to be focusing on question 3. Remember, this is a past paper for June of 2022. If you need more questions, please check in the description of this video. There's all the questions for the paper, the links to the videos that I did. I just did each question separately, right? Anyways, let's solve this question 3. So what we have here is we are having a geometric sequence, right? We are having a geometric sequence of 1024, 256, and 64, right? And we are asked to calculate the 10th term of the sequence, right? So what we're going to do is we're going to first identify the a value of the sequence. A value is 1024, and then our r is equals to term number 2 over term number 1 is equals to term number 3 over term number 2, right? So which means this is term number 1, this is term number 2, this is term number 3. So we're going to divide that out, and we're going to get r being equals to 1 over 4. Please do that, check and confirm, but my r I found to be equals to 1 over 4. Anyways, so now we want to find t of 10. So Tn is equals to ar to the power of n minus 1. So this is the general formula of a geometric sequence, right? So T of 10 is equals to, we know our A value is 1024. Our R is 1 over 4, right? 10 minus 1. So please punch this in your calculator, everything. So it's 1024 multiplied by 1 over 4 all to the power of 10 minus 1. So please punch it out, and the answer I'm getting is 1 over 256. So this is the 10th term of the sequence, right? So we're done with 3.1.1. Now we move on to 3.1.2, right? So in 3.1.2, we are asked to find the sum of this problem here, right? We are given the sum, the whole thing. So we need to calculate the value of the sum, right? And always, I know I know for a fact that this is actually this sequence here, right? But we don't have to assume that. We just need to prove that and just solve it according to the way we know it, right? So we're having a sum where it's 8 at the top, p starts at 0, and then you have 256 into 4 to the power of 1 minus p, right? So what you need to first do when you have this and you want to identify the sum of this, you need to first identify the first 3 terms of this problem here. So when p is equal to 0, what is the term? So it's going to be 256 into 4 to the power of 1 minus 0, right? And then the answer, if you punch your calculator, you're going to get this here, which is 1024, right? You do the same for p is equals to 1. 256 into 4 to the power of 1 minus 1, you're going to get this term here, which is 256. And then p is equals to 3 is 256 into 4 to the power of 1 minus 2, right? And you're going to get 64. So now we know that, okay, fine, this definitely gives us this here, right? So anyways, so now we know our first 3 terms, right? We're just going to write down our first 3 terms. So we're just approaching it in the most basic way possible. So our first 3 terms is what we have here at the top. It's 1024, 256, and 64, right? Obviously it continues. So our A value is equals to 1024. Our R we found to be 1 over 4 in the previous question, right? And now we need to identify N, right? Because we want to find the sum of this. So N is found by saying top minus bottom plus 1. What is top? Top is this here. This is top, right? What is bottom? Bottom is here, right? And then plus 1. So top, we're going to say 8 minus bottom, which is 0 because the sequence starts at 0, plus 1. So meaning our n value is equals to 9, right? And then we can find the sum. So sum of 9 terms is equals to, obviously using the Sn is equals to a into 1 minus r to the power of n over 1 minus r, right? So using that sum formula for a geometric sequence, right? And the a value, we know it to be 1024, so it's going to be equals to 1024 into 1 minus our r is 1 over 4, all to the power of 9, and 1 minus 1 over 4, right? And the sum of 9 terms the sum of this problem here, you should get something like 87381 over 64, right? If you write it in decimal form, you should get 1365.328, right? So this is your sum of 9 terms, right, of the sequence. Anyways, now let's go to the last question of question 3, right, which looks more interesting, right? I hope you guys are enjoying. If you're struggling with anything, please let me know in the comment section below. If there's any question that really troubled you. If you haven't subscribed to the channel, please do subscribe. Thank you so much if you have. Let's do question 3.2, right? Question 3.2, we are told that the first two terms of a geometric sequence are as follows. So meaning this is term number 1 and this is term number 2. And we're asked to determine t if the sequence converge, right? So term number 1, we are told it's this one here. Term number 2 is this one here. And remember, this is a geometric sequence, right? This talks about convergence. Obviously, they told us here. But we know very well when they talk about convergence, we always think of a geometric sequence. So now we first need to identify our R before anything else, right? And then because whenever they talk of convergence, you always have to think of R lying between -1 and 1, right? And for us to find T, it means we first need to find R, right? So that we'll be able to find T. So the first step to do that is by finding R. So R is equal to term number 2 over term number 1, right? What is term number 2? Term number 2, it's this one here, which is t to the power of 3 plus 9t to the power of 2 plus 27t plus 27, right? Divide by term number 1. Term, obviously, it's over 2. Let me just write this properly so that we are able to see it clearly, right? So it's going to be R is equals to term number 2, which is t to the power of 3 plus 9t to the power of 2 plus 27t plus 27, right? It's over 2. And it's divided by what? So let me put brackets here. It's divided by term number 1, which is minus t to the power of 2 minus 6t minus 9, right? If you were to write it properly, it's going to be R is equals to t to the power of 3 plus 9t to the power of 2 plus 27t plus 27, right? And then here it's going to be multiplied by 1 over minus t to the power of 2 minus 6t minus 9, right? It's over 2, right? So this is R, but obviously you need to simplify this further. For us to simplify this further, we need to factorize this cubic function, right? Chances are it will give us a factor which is more or less like this, right? So let's just try and simplify it and see what we're going to find. So to simplify this, I'm just going to say, so we're having R, okay, obviously don't have to write R. I'm just going to write down this here. I'm just going to write down that. So it's going to be t to the power of 3 plus 9t to the power of 2 plus 27t, right? Let me just write it down here. So we're having t to the power of 3 plus 9t to the power of 2 plus 27t plus 27. So we want to factorize this. Remember, synthetic method. If you haven't done it, you please go and check it out. It's under calculus, so where you need to be able to factorize a cubic function, right? So to factorize the cubic function, you're going to first test t values. Try t is equals to 1 and see if it's going to give you 0. And try t is equals to -1, try t is equals to 2, try t is equals to -2, try t is equals to 3, or t is equals to -3. And when I was trying all these values, I found that this t is equals to -3 gives me a value which is 0, meaning that it is a factor. Remember factor theorem, it says that. So it is a factor of this problem here. So meaning I'm just going to use it to factorize this. So it's going to be t equals to -3. Let me write this properly so that you see clearly. So it's going to be like this. And then t is equals to -3. And I'm just going to write down this as is. it's going to be t to the power of 3 plus 9t to the power of 2 plus 27t plus 27, right? And we always start at 0 when we solve this, and it's plus here. So what you do is you add the coefficient. So the coefficient of t to the power of 3, it's 1. So there's 1 here. So at 1 plus 0, it's 1. And then that 1, you multiply it with this 3 here. The minus 3, by the way, so it's going to give you minus 3, right? And then do the same thing. 9 plus minus 3, excuse me, which is 6. 6 multiplied by minus 3, it's minus 18, right? And then 27 plus minus 18 should give you 9. 9 multiplied by minus 3 should give you minus 27. So your remainder should always be equal to 0. So this is called the remainder, right? So we are done factorizing. So we have t, obviously this is t is equal to minus 3. If you write it properly as a factor, it's going to be t plus 3. And then we write down this here, which is a quadratic formula. This here, what's in here is a quadratic. So a quadratic, normal quadratic, it's ax squared plus bx plus c, right? And so it's going to be t plus 3. And then my a value is going to be this one here. This one here is my a value. So I'm just going to write down x squared. And then my b value is the 6. So I'm just going to write down plus 6x. And then my c value is 9. So it's plus 9, right? So then we are done. For now, obviously, let's go and put it into our equation of r and see if it's going to give us something, right? So remember we were here, and I said we want to simplify this r here. So with the simplification done, this here is going to be t plus 3, and then t squared plus 6t plus 9, right? If we take a look at this, this is the same as this here at the bottom. So it means obviously over 2 multiplied by 1 over. So it means now just going to write down minus t squared minus 6t plus, oh, minus 9, sorry. It's going to be minus 9. So it's minus 9. So they are the same, right? As I indicated, they're the same. So they're going to divide out. I mean, this will divide out this. Obviously, will remain with a negative. Actually, let me not divide out now, so that you guys can see what happens first, because they're not exactly the same. This is minus. Everything has minuses. These are positive, right? So we can do r is equals to t plus 3, right? And then t squared plus 6t plus 9 over 2 multiplied by 1 over, I'm just going to factor out the negative, and then you have t squared plus 6t plus 9, right? Now you can divide out. You can divide out this and this. Then you remain with the following. So let me just erase everything that's at the top. Remember, we are trying to find the value of t. That is the whole purpose of this question, to find the value of t. So for us to find the value of t, we need to first find the value of r. Not necessarily the value, but we need to find r with what we have, right? So now that we divided out this and this, the negative, don't forget it, it remains. So my r is going to be equal to t plus 3, which is this one here. Remember, it's divided by 2 multiplied by 1 over minus 1. So this minus 1 will multiply this 2 here. So we're going to have r is equals to t plus 3 over minus 2, right? So now we have direction on how to solve this problem, right? So remember, we want to find the value of t. So, and we're told that this sequence converges, meaning r lies between minus 1 and 1. So instead of in place of r, we're going to put in this expression here, which is just going to write down. So it's t plus 3, right, over minus 2, and it's less than minus 1, less than 1. So I'm just going to cross multiply the negative 2 on both sides. So it's going to be, let me write it down here. So it's going to be minus 1 times minus 2 less than t plus 3, and then 1 times minus 2, right? So this 2 will multiply this and also multiply this, hence I did here. And then you're going to have t plus 3, right? And remember, it's less than here, the sign. So it's less than minus 2, less than 2, right? So now we're just going to transpose the the 3 on both sides. If you can check, let me just write it properly here. So I hope you guys are enjoying this problem. It looks interesting, right? So it's t plus 3 less than minus 2 less than 2, and then you transpose 3 that side and also that side. So you have 2 minus 3 less than t less than minus 2 minus 3, and then you have t which lies between minus 1 here, and then here it's minus 5. So this is your solution of t. T must lie between minus 1 and minus 5, right? That is the solution of this problem here. If you are facing any challenges with whatever problem I was solving in this video, let me know in the comment section below. If you need any other question, because this is a past paper for June 2022, check the description of this video. You will see other questions, your question 4, your question 5, all the way up to the end of this question paper. Thank you so much for watching. Please subscribe if you haven't subscribed, and like this video.